Hi everybody, tonight's video is going to be talking about distance, and distance is defined as the length between 2 points. Last video we talked a little bit about measure, linear measure, and the difference is with measure we're usually going to have like an actual unit of measure, so like inches, centimeters, something like that. With distance we're just talking about units in general. So it's very easy when it's something like 2 points on a number line. So in this case, if I were to take, let's say, point A here and point B here, it's very easy to figure out the distance between those 2 points. I could simply count how many units there are between them. So 1, 2, 3, 4, 5, 6, 7, 8. So the distance between A and B, I could write that as lowercase script d equals 8 units. Another way that I can write that is I can say the distance between AB, or like remember we said the measure between AB, a line segment doesn't really need the line at the top, equals the absolute value of -6 minus 2, right? So another way to calculate distance is use the absolute value of the 2 points, subtracting the 2 points. So in this case, -6 minus 2 would give us -8, and the absolute value of -8 is 8. So that's like the formal way to compute the distance. The easy way is just count the points. As simple as that when you're talking about 2 points on a number line. However, we're not always going to be on the number line. We are going to be looking at 2 points on a coordinate plane. So when that's the case, we have something that's called the distance formula to help us calculate that. And the distance formula is d, or distance, equals the square root of the quantity x2, or x sub 2, minus x1 squared plus y2 minus y1 squared. And what are x2, x1, y2, and y1? Those are the coordinates of points on the coordinate plane. So x1 comma y1 are the coordinates of a point, and x2 comma y2 are the coordinates of a point. So where x1, y1, and x2, y2 are points on the line, or the line segment that we want the distance for. So what's this look like? And this hopefully is review, but quick review. This is a coordinate plane, okay? There are 4 quadrants. We could talk about those later. There's the x-axis here and the y-axis there, all those different parts. But this is ordered so that we can describe the points, or the coordinates of each point on this plane. So let's put a point right here, and we'll call that point A. What are the coordinates of point A? I go over 1, 2, 3, 4 units on the x-axis and up 1, 2 units on the y-axis. So that point is at 4, 2. In other words, if I'm going to find distance between A and some other point in a second, 4 is x sub 1, and 2 is y sub 1. Let's find another point on here to use. Let's put a point right down here. We'll call this point B. And what are the coordinates of B? Well, it's over 1 in the positive x-axis, and down 2. So we go down to the negative y-axis. So the coordinates for the point B are 1 comma -2. In other words, 1 is x sub 2 and -2 is y sub 2. Now, the distance for this is kind of like a diagonal, right? So I can't really just say like, oh, that's like 3 units or 4 units or anything like that. I need to be a little more precise. So this is where we're going to use our distance formula. And every time we use the distance formula, we want to write it out. So we're going to say d equals the square root of x sub 2, sloppy x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared, right? So we want to just get in the habit of writing that out each time. That way we'll memorize it pretty easily. So keep along your square root, and now we're plugging in our numbers. So x2 is 1 minus x sub 1, which is 4. I'm going to take quantity squared, plus y sub 2, which is negative 2, minus y sub 1, which is 2, quantity squared. And so now I have the square root of 1 minus 4, that's negative 3 squared, plus negative 2 minus 2 is negative 4 squared. So now I have negative 3 squared, which is 9, plus negative 4 squared, which is 16. And 9 plus 16 is 25. So the distance between A and B, or the distance of that line, is the square root of 25, which happens to be 5. That's nice. It worked out as a nice whole number for us. But in some cases, that's not always going to be the point. So that's why we're going to need to have our calculators handy when we're taking the square root. We'll round to a couple decimal places, and sometimes it'll work out nice like this, and sometimes not so much. If this were just two straight points on a straight line, then it would be easy again. So if we had point C and point D up here, again, we could just count the spaces, your units, 1, 2, 3, 4, 5. That would be a 5 unit. The distance between C and D would be 5 units. But again, when they're on a diagonal like this, that's when we're going to want to definitely use the distance formula here. And sometimes it'll work out nicely. Sometimes we'll have to round our decimal point, but that's okay too. So that's basically it. A couple examples on using the distance formula, or I should say one example on using the distance formula, because I think this should be review for all of you. So we're going to do some problems like this tomorrow in class. If you need some more review, think of some questions to ask about plotting points. You can practice plotting points on a coordinate plane. Remember labeling all your parts of the coordinate plane, and we'll do some more examples in class tomorrow. Have a good night.